Hello everybody, today we're taking a look at Unit 1, Multivariable Functions, dealing with patterns of change. Our learning objective is I can recognize patterns of change between the variables in multivariable situations and functions. Alright, so let's take a look at an example here. So what we're going to do is put you in a multivariable situation and determine what happens as one variable changes. What happens to the other variables? All right, so we're going to deal with fuel efficiency in your cars right now. So fuel efficiency is an important factor to consider when you're buying a car because it can cost you hundreds of dollars. In fact, a difference of 5 miles per gallon will cost you around $500 more over the course of the year. Fuel efficiency, which we're going to use variable E, can be determined by taking the total miles driven, M, and dividing it by the number of gallons used, G, to give a unit of measure called miles per gallon, which is pretty commonly known as MPG. This is your miles per gallon. So use the table and graph below to recognize the patterns of change in this multivariable situation. So what I did, I have 6 cars here, all kind of different sizes. And what we have here is the number of gallons they used on a 500-mile test track. So all these cars drove a total of 500 miles. And this is a recording of how many gallons of gas they used on that 500-mile trip. So the distance was actually kind of fixed here, and we were recording how much, how many gallons of gas were used. So what we're going to do is we're going to graph it and then answer a few questions talking about the relationship between the variables. What I'm going to do first is I'm going to set up the equation that I was kind of given within this word problem. It says here, fuel efficiency can be determined by taking the total miles driven using variable M and dividing it by the number of gallons used, G. So fuel efficiency is your miles driven divided by your gallons used. And that's your miles per gallon, which kind of makes sense, right? So I'm going to write that with just our words first. So fuel efficiency, I'm going to shorten that. That's equal to your miles divided by your gallons used, right? And you can kind of see our miles per gallon here, right? Now to put this in variables, our fuel efficiency, we're using E for efficiency, and that is equal to our M and divided by G. All right, so fuel efficiency is equal to our miles divided by our gallons, which makes sense, miles per gallon. All right, so let's take a look at these 6 cars, and then let's kind of graph them on this graph by plotting those points and figuring out kind of what the pattern of change here. So this graph is going to be your gallons used versus your fuel efficiency. So I'm going to use gallons used on this axis here. I'm going to see what happens as we increase our gallons used. What's going to happen to our fuel efficiency? Okay, so this is going to be our fuel efficiency. All right, I'm going to save some time there. Let's take a look at our gallons used for the 6 cars. Looks like we have a range with our lowest being our hybrid, around 9.8 gallons used, and our highest was a large truck, used 47.3. So on this axis, I need to scale this out so I cover all of this data here. So our origin here, of course, is going to be 0. It looks like if I count every 2 lines, I need to at least cover 50, because that's, a little bit more than 47. So if I count by tens here, that should cover me. 10, 20, 30, 40, 50, and we don't have up to 60, but that's fine. And then our fuel efficiency, we actually don't really know what our fuel efficiency is, but we're going to solve for that because we are actually given our miles in this situation, and we are going to divide that by how many gallons are used for each car. So in this case, our fuel efficiency, our miles was set at 500, right? If we divide that number by our gallons used, then we'll know what our fuel efficiency is here. Okay, so let's take a look at what our most fuel efficient car will be. This 9.8. So if I go 500 divided by 9.8, 51 miles per gallon is my most efficient. So similar to this here, I'm going to count by tens here. 10, 20, 30, 40, 50, and 60. And I'm doing that because I know that there's not a car that's not more efficient than 60 miles per gallon. All right. So I'm going to put my calculator here, and I'm going to start plotting some of these points. Remember, I'm using gallons used and fuel efficiency. I'm given the gallons used, and I need to use this equation here. I'll circle it. To figure out what our fuel efficiency is. Remember, this is our E, and this is our G here. All right. Okay, so if we're going for the compact car, that's going to be 500 divided by our 16.5. So 500 divided by 16.5 gives us a 30.3 fuel efficiency. So the compact car uses 16.5 gallons, which is about here, and just over 30, about right there would be our compact car. Gallons used versus fuel efficiency. All right. Let's look at our hybrid, which I did that one earlier. 500 divided by 9.8, 51.02 is our fuel efficiency. So the gallons used was 9.8, and our fuel efficiency is 51. All right, so that point is about right there. All right. Large truck, 47.3 gallons used. All right, so let's take a look at that. 500 divided by our 47.3. 10.57. That is not a very good fuel efficiency. So as our gallons used goes up to 47, fuel efficiency is about 10.5. So that's pretty close to 10 there. All right. Small SUV is going to be 500 divided by our 23 is a 21.7. So 23 gallons used. 21.7 fuel efficiency. Mid-size car, 500 divided by 21.1 gives us a 23.6. Mid-size car, so 21 gallons used, 23. Notice those two are actually very similar to each other. And lastly, our large SUVs, 36.8, 500 divided by 36.8 gives us a 13.5. So let's see, 36.8 was our gallons used, and 13.5. All right, so there are our plotted points for our 6 cars using our gallons used and our fuel efficiency. Now you'll notice that there's kind of like a curve to this pattern. Like it comes down pretty sharply at first, and then it looks like it levels off, which is kind of interesting. So I'm going to kind of sketch, like, of course these are not exactly our cars, but as I sketch it, it kind of looks like it's doing something like this here. It's not a straight line going this way. And that kind of makes sense, because if this was a straight line, that would assume that this would go below 0 And for fuel efficiency, that doesn't really make sense. You can't have a negative fuel efficiency. So it kind of would make sense if this would curve off. All right, so let's take a look at the patterns of change. Questions. So as the number of gallons used increases, what happens to the car's fuel efficiency? So we're looking at the number of gallons used. As this increases, so as we increase our number of gallons used, what happens to our fuel efficiency? So it looks like as we use more gas, the fuel efficiency is going to be going down, right? As we use like a little bit of gas, we have a very high fuel efficiency, like 50 miles per gallon. But then as we use more and more and more gas, our fuel efficiency gets closer to 10, okay? But it's not like a straight line like I described before. It's actually going to kind of curve. So how would I describe this in words? I would probably say that so number of gallons increases, what happens to the fuel efficiency? So the fuel efficiency, decreases. But it's not going just like, that's not quite enough. It does go down, but it's not going straight down. So it decreases at a slower rate, right? Because notice it goes down really steep. It goes down a lot right here. But as we make this jump from here to here, it doesn't drop nearly as much as it does from here to here, right? So as we go from like 10 gallons used to 15, it drops a lot. But if we go from like 40 to 50, it really doesn't drop that much. So you notice that this is a high, it drops a lot. And this one just drops a little bit. So the fuel efficiency is decreasing, but at a slower rate over your number of gallons used. So that kind of, hopefully that makes sense a little bit. Let's take a look at the second question. So in this case, the miles driven was fixed at 500 miles. What would happen to the number of miles driven for each car if the number of gallons used was fixed at 15 gallons? So instead of every car driving that 500 miles, now they're going to use 15 gallons of gas. So every car, you fill up 15 gallons of gas, right? So what's going to happen to the number of miles driven for each car if you put in 15 gallons in each car? So what that tells me is if I put in 15 gallons into this hybrid and the large truck, obviously the hybrid is going to drive a further distance than the large truck because it has a better fuel efficiency. All right. So it's nice to look at those two extremes. So to answer this question, what would happen to the number of miles driven? The miles driven for the cars with higher fuel efficiency would increase. All right. So the miles driven for the cars with higher fuel efficiency would increase. So the hybrid drives the farthest on 15 gallons. All right. All right. So hopefully that helps out. And if you flip to the back side, there is another problem for you guys to do on your own on electricity. Thank you very much. Bye-bye.